Have you ever had to multiply or divide fractions? Yes, and most of the time when you do, you grab your calculator. Jerks. We are going to have to be able to do this without grabbing our calculator, because while we can do questions like this in our calculator, we cannot do these in our calculator. Okay? So let's talk through the steps that we do when we do a problem like this, because the same steps that we're going to do for a problem like this, we're going to do for a problem like this. Okay? When we multiply fractions, what do? I'm multiplying a fraction. It's not two fractions set equal to each other. There's nothing to solve, so I'm just multiplying. So how do I multiply fractions? Straight across, straight across. Okay? If it's two fractions set equal to each other, I'm going to cross multiply. But it's not. That's not what's happening here. It's just one fraction times another fraction. So I multiply numerators and denominators. So for this, what's 3 times 15? I'm going to tell you the answer. What's 3 times 5? 15. And what's 4 times 7? 28. So how do you suppose we would do a problem like this? Same way. What's 2 times x? 2x. What is x minus 4 times x plus 1? Look, x minus 4 times x plus 1. Done. Okay? Because of what's going on later, and you'll see what I mean hopefully later, I want to leave it like that, unless it specifically says to multiply it out. And if I want you to multiply it out, I will specifically say multiply it out. Fair? Okay. Did I multiply these two? I did. I just wrote them beside each other. That implies multiplication, right? So I did what I was supposed to do. I don't need to go any further than that. Okay? What about a problem like this? What do I do here? I put a 1 underneath a 2. And then do exactly what I did above. Multiply numerators and multiply denominators. Okay? So what kind of steps are we going to write right here? What steps did I do? So I make the whole number a fraction. So I did the number over 1. And then, now this is some fancy math stuff, so watch. And then do that. So what is 2 times 4? 8. What is 1 times 9? Done. So how would I do this problem then? 3 over 1. So it's 3 times 8. 24. What is x plus 6 times 1? X plus 6. Now I'm going to take a minute for a commercial. Okay? Oh, first of all, before the commercial, we always say, you've been watching Days of Our Lives or something like that, right? Okay? So we've been doing what? Multiplying and dividing rational expressions. What makes something a rational expression? It looks like a fraction. Okay? Where is the variable? Mostly it's in the denominator. It can be in the numerator. This one's in the numerator, but it's in numerator and denominator, right? Because if I have 2x over 6, is that a rational function? Or a rational expression? It's not. It's just 2/3, or 2, what did I say? 2x over 6? So it's just 2/6 times x. That's not a rational function. Okay? It's really only a rational function when we've got something in the denominator that I don't know. Okay? So, very quickly, this is the answer that I just got, 24 over x plus 6. Now it's time for the commercial. What am I allowed to simplify in a fraction? If I have 10 over 12, what am I allowed to simplify? By how? How do I simplify it? They're both divisible by 2? right? So the math that's going on behind this becomes 2 times 5, and this becomes 2 times 6. And what can I simplify? The 2, because it is the common factor, right? I can simplify common factors. Can I simplify 24 and 6? Is 6 a factor of x plus 6? Can I factor a 6 out of each term right here? No. So what you're telling me to do, if you're telling me to simplify 24 times 6, or 24 and 6, you're telling me it is okay to simplify the fraction 1/17 over 1/19 by crossing out the 1s and crossing out the lines over here to get an answer of this. That's ridiculous. You know it and I know it. So why would I tell you something like that? Well, usually you guys remember ridiculous stuff. Okay? If you can do this, you can also do that and simplify 24 and 6. Can you do this? So can you do that? No. You can only simplify common factors like this. Okay? You have to be able to factor something out of the whole numerator, something out of the whole denominator, not just part of the denominator. Because if I can simplify part of the denominator, I can do this. So when I'm asking you about simplifying something and you try to do this, I'm going to remind you of 17 over 19. And I'll probably just say 17 over 19. 17 over 19, really? I needed you to know what I meant when I said 17 over 19. Okay? All right, back to the show. So, what do you know about this? Can you simplify it? No, that's the answer, right? Okay, how do we do this one? X plus 1 over 1, and then 8 times x plus 1 over x plus 6. Can I go another step if I want? Yes, do I want? No. This is a perfectly acceptable answer, just like this. Okay? So look at number 3 for me right here. Example number 3 right here. How is it any different from 1 and 2? It's mostly not, right? It's multiplication. But do you notice that there's a common factor in the numerator and in the denominator? So there's 2 different ways we can go about doing this. Number 1, we can multiply straight across like we've been doing and get 4 over 36, which would be simplified to be 1 over 9, right? The other way we can do it is we can simplify first. 4 divided by 4 is 1, isn't it? So that's a common factor, so I can simplify that out. And what I'm left with is 1 over 9. Is there a right way versus a wrong way? No. Is there a quicker way? Typically the second way is quicker, isn't it? You have smaller numbers that you're dealing with because you simplified first. So we're going to say simplify, then multiply. You can still get the right answer if you multiply first and then simplify. I just want to be clear about that. Okay? So in this rational expressions example, what do we want to do first? Is there a common factor in the numerator and in the denominator? What is it? Okay, so that made me really happy. You have to know that. Okay? Because you know what other people want to do? They want to cancel out the x's and cancel out the 3's. Is that a common factor? No. The x plus 3 is common with the x plus 3, and that's what we can simplify. I can't just simplify the x's and the 3's. It's like a group. Okay? So 2x over x minus 1. So now I can cross out the x's. You're not going to argue? Is x a factor of the numerator? Yes, it is. Is x a factor of the denominator? No, it's not. Something's being added or subtracted from it, right? So it's not a factor. It's part of a number that's down there. So can I cancel out the x's? No. So I am done. Okay? Number 4. So we want to simplify again first, right? So the difference between 3 and 4 is that 3, the example they showed you, you got a direct simplification, 4 over 4. It just simplifies to 1. Do you have that at all in number 4? No. So we can simplify 4 and 6, right? Because they're both divisible by 2. So this leaves me a 2 up here and a 3 down here. And then I have a 5 and a 15, so that simplifies to 1, and that simplifies to 3. Ooh, I've got 2 3s. So simplify those. Oh, they're both in the denominator. When can you simplify something? Common factor in the numerator and in the denominator. Very good. Okay. So what do I have left to do now? Multiply 2 over 9. Good. So the steps for number 4 are what? Same as number 3, right? Simplify, multiply. Now, I said something over here that I need to correct real quick because, you know, I like to use my correct math vocabulary. I said I want to cancel these two things, okay? It's not a movie ticket. It's not a train ticket or an airplane ticket. We don't cancel it. We simplify it, okay? I think you guys have always said canceling, and maybe some of your lower classes you said canceling. And I suppose down there it's okay, but when we get to high school, we are really, really trying to use our correct math vocabulary. Okay? Canceling is not correct math vocabulary for us. We are going to simplify. Fair? Okay, so what do we want to do here then? You know what people want to do? I'll show you what people want to do. Cancel out the x's. Cancel out the 3 and the 9, because that's what we did over there, right? Can you cancel parts? 17 over 19. Can you do that? Okay, so what do we have to do? Factor. Can I factor my numerator? No, it's already low, right? What about my denominator? Ooh, what multiplies to be 20 and adds to be 9? 4 and 5. So x plus 4 and x plus 5. Okay? Can I factor my numerator? No, that's the lowest. Can I factor my denominator? Not like this, but they're both divisible by the same thing, right? So can I factor out a 2 and get x minus 3, right? So what simplifies? The x minus 3's simplify. Is that it? The x plus 5 simplify. So you want me to tell you the wrong answer that a lot of people tell me is correct? 2 times x plus 4. That's all that's left. How is that not the right answer if that's all that's left? Yeah, guys, look. What did I simplify? I simplified an x minus 3 with an x minus 3. What do you get when you say x minus 3 divided by x minus 3? A 1. That's not all that's left. There's a 1 here, 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 and here, right? Now, normally we don't write the 1 because we know it's a 1. But especially if you're a visual person, you might need to remember there's a 1 up there so that this is the actual answer that you get. I just saw a couple light bulbs. Makes me happy. Excellent. Any questions? Forgot to do that. Okay, number 5. Do we ever divide by fractions? Sadly, never. We never divide by fractions. We're not supposed to divide by fractions. What are we supposed to do? Multiply by the reciprocal. Good. Okay. I'm saying this divided by this, so this is the one I take the reciprocal of, what I'm dividing by. Okay? What is the reciprocal of 1 over 8? So really this problem is 2 over 3 times 8 over 1. Is there anything I can simplify? No. So I get 16 over 3 because I just multiplied straight across, just like all these other examples I already showed you. Is dividing really any different? Only one step different, right? You have to remember to multiply by the reciprocal. You have to take the reciprocal of that second fraction. Now, typically people say to me, well, does it matter which one you take the reciprocal of? Oh, yes. Matters very much, right? I am multiplying by, I'm dividing by 1/8, so I need to multiply by its reciprocal. It's not the first one, okay? So what are my steps? Take reciprocal. And then that. How about that? Excuse me. So this problem now becomes, ooh, can I factor as I go to make it easier for myself later? Okay, 2 times x plus 2 over x plus 3 times what? What's the reciprocal? X minus 2 over 5. All right, what can I simplify? The x's. What 2? Right here? I factored the numerator. I factored a 2 out of each of the terms. Good question, though. I'm sorry. What do I simplify? I got my purple marker out to simplify. What do I simplify? But I want to simplify something. Too bad. Okay, fair. 2 times x plus 2 times x minus 2 over 5 times x plus 3. Done. If there's nothing to simplify, you can't simplify anything just because you wanna. Last problem, last example. 3 over 2 divided by 1/8. That problem becomes?
2 times 8 over 1.
Perfect. Ooh. So that's a 1 and that's a 4. So your answer is? 12. 12 over 1 or just 12, right? Okay. So take reciprocal. Simplify. Multiply. Was that too fast? Yes. 4 over x plus 3 times what? What's in the numerator of this fraction? I know I'm taking the reciprocal of this, but I'm trying to factor as I go. Are you okay with that? So x plus 1 and x plus 3. Right? It has to multiply by 3 and add to be 4. Is that 1 and 3? Yeah. And then x minus 7 in the denominator. This time, are you going to let me cancel anything? Simplify anything? Ooh, x plus 3 and x plus 3. That simplifies, doesn't it? So I get 4 times x plus 1 over x minus 7. Ooh, I can cancel my x's. 17 over 19, right? Can't do it. So I'm done. Remember, when can you simplify a fraction? When you have a common what? Factor in the I'm going to put it this way, and the denominator. It's got to be one in the numerator and one in the denominator for you to be able to simplify them. Okay? Any questions? Okay, those are the notes. And you have the homework page? Yes? Now, there's 9 on the front and 9 on the back. So please circle the following problems. We're going to fill in the top in just a second, but I don't want to forget to tell you. Okay? Number 1, this is on the front. Okay? Number 1. Number 6. What? Okay. Number 8. Number 4. Number 6. And number 9. Okay? That gives you 6 total problems to do, and that gives you quite a bit of extra if you want to get extra points. Okay? Any questions?